Okay, so in this next set of videos, we're going to focus on heat and heat transfer and changes and phase changes. And so let's dive right into this. So heat, right, is a spontaneous transfer of energy due to a temperature difference, right? So we talked about this before. It's the flow of the energy, right? So the hot temperature item is trying to heat up or trying to give the colder temperature item more energy, right? So because heat is a form of energy, it has an SI unit of joules. Okay, now in chemistry and so forth, you talked about the calorie. So the calorie is a common unit of energy defined as the energy needed to change the temperature of 1 gram of water 1 degree. Okay, now remember, this 1 degree can be 1 degree Celsius, it could be 1 degree Kelvin, okay, because remember, the temperature differences between the two are the same. All right. Now, the most common unit of heat is what we call the kilocalorie. Right, or KCAL, right? Calories abbreviated CAL, right? Now, make sure you don't capitalize it because of the next particular reason. Okay, so it is the most common unit because this is the food calories. And so when we talk about calories of food, we capitalize calories where the capital C calories is a kilocalorie, right? And so we've been talking about for a couple of units now energy being in the SI unit of joules. Well, that's named after James Prescott Joule, who performed a bunch of experiments, and he established what is called the mechanical equivalence of heat. I'm going to run out of space. Okay, which is the amount of work needed to produce the same effects as heat transfer. And so you had this like contraption, right, where it was like spinning. So this piece like spun. There was like it was in a liquid, and so this spun, right? He hung weights, and it caused it to spin. And so this stuff spun inside, and he was able to take some calculations. And so he was able to come up with this mechanical equivalent of heat and a conversion factor between kilocalories, right, and joules. So 1 kilocalorie, so 1 kcal, is 4,186 joules, right? Or you can say 1,000 calories is 4,186 joules. All right. Now, when heat is added or removed from a system, it changes the internal energy and thus its temperature. We've talked about this, right? We talked about this way back, I think, in the first video for this unit. So when I heat something, I add energy. When I cool something, I remove energy. So what is it going to do? It's going to change the temperature. And so one thing to note is that adding heat does not necessarily increase the temperature. Okay, so one example would be melting ice. So technically I am increasing the heat, right? Or excuse me, I am adding heat, but I'm not increasing the temperature. What am I doing at ice? Because I'm changing the phase. Okay, and we're going to get into this. This heat that we add, right, is what we call latent heat. Right? So we're increasing the heat, right? But we're not increasing the temperature. Okay. Now, here in the last bullet point for this particular section, I apparently stapled my document wrong. So one thing to note is that work done on the system or by the system can also change the internal energy of the system. Okay, and so what we're going to do is we're going to look at the first thing we do is we're going to break these problems down into first looking at what happens when we change when we add heat and we change the temperature, and then we're going to look at what happens when we add heat but don't change the temperature and kind of put it all together. This is calorimetry from chemistry, if you remember that.